So we are going to be taking a peek here at the preview for our first quiz. Now, this is going to include the stuff we've been up to, of course, these last few days, but I'm warning you, I might throw an application in or two from what we've been doing also that may not be directly on here. It won't be something totally off the wall, but it may look a little different, just saying. All right, state whether the functions represent growth or decay, give the y-intercept and the end behavior. Now you'll notice here, I should have put a spot in for the end behavior. We'll do it up here. Before I type this in on the calculator, because that could help me out with a few things, how can I tell if this one's going to be growth or decay before I ever get started? Before I look at the graph, what could I do to figure out if this is growth or decay? Look at the b value. So what's that tell me?
It's growing.
It's growing, okay? It's greater than 1, so it's growing. I also should be able to tell what the y-intercept is before I ever start. Because there's a direct relationship, unless there's a shift, between my a value and the y-intercept. Now let's see if I'm right. Growth, good. If I look at my chart and get back somewhere near 0, there we go, I notice my y-intercept is 0, 3. Now, of course, I could look at the graph. I could just look at the chart for the y-intercept, but there are some things that just make things go faster and make them easier. So as far as my graph goes, what would my domain be for this? Negative infinity to infinity, and that's the domain every single time. That should be the easiest part of this quiz tomorrow, is anytime you're asked for the domain. Negative infinity to infinity, all reals. What about my range, my bottom to top with my y's? 0 to positive infinity. This graph doesn't keep on going down forever. It levels off right here at the x-axis, which is a y value of 0, and keeps going that way. So that's what we want to do for that one. Now, the end behavior, which I didn't put a slot in here for some reason. Remember, easiest way to go, get the x values in first, because we know we're going to have it going to the right towards positive infinity and going towards the left towards negative infinity. The question becomes, once we get a picture of the graph back up, what's happening to y? So I look and I say, okay, as my x values go to the right, what's happening to y? It's heading towards positive infinity. It's heading upward. So we put that in. But what about when my graph is going to the left? What value am I approaching? 0. Okay, there's always going to be a direct connection between the values that you use for your range and your y values for your end behavior. You'll always use the same ones for both. It just may depend on the order that they're in. So a little hint that might help you out. Number 2, we're doing the same thing, but I threw a twist in on you. Now, in initial looks, does number 2 look like it would be growth or decay? Originally, it looks like decay, right? Because my b value is my b value is 1/2. But what else is a little different about this one? It's a negative exponent. The negative exponent causes us a little bit of a different issue here. Because now when I go to graph it, wait a minute, now it's like growth. Here's why. Remember, when you have the negative exponent, that causes your b value to act as though it's the reciprocal. This is going to act as though it's this. So that's why I'm seeing the growth here instead of it being decay. It's making that kind of mirror that we talked about before. It doesn't affect my y-intercept. It's still going to be 0 in my a value because there were no shifts, but I can always check on the calculator. There it is. When my x is 0, there's my y value. It still doesn't change my domain. That's still the easiest points on the whole quiz. What about my range? And it's still 0 to infinity. Bottom to top. So that's the type of thing that we're looking for on these. And again, end behavior, since it looks really similar to the last one, basically is going to be the same as the last one was. Because as we head to the right, my graph is still heading towards infinity. As my x values are heading to the left towards negative infinity, my graph is quickly approaching 0 this time. But again, be cautious for that when you're doing them. And even put the negative infinities, kind of draw a picture and put them there if you need to. So we simplify life once we get through those first two and start heading towards 3 and 4. Yes, sir?
So I wanted to check this because this is how it started to end up on some of my worksheets.
Okay.
Is it possible that instead of ending on 0, like where it stays flat, is it possible that it stays flat on another number?
If there's an up or a down shift, absolutely. And we're about to talk about that right now.
Okay.
So for instance, if I get here, hello, sir. So when I go to punch this in, the only thing that typically gets people on this section is not typing things incorrectly. Now this first time, I don't want my exponent in parentheses because the -2 isn't part of the exponent. So when I go to graph this, I'll take a peek here. This may be what we were talking about a second ago. My graph's shifted below the axis now. So I still want to get some points because I want my graph to be accurate. I don't have to go crazy and do like, 10 points or something, but I do want to get enough points that I can get an idea, oops, gotta go below here, of where things are heading towards. Because my key when I'm doing these is making sure that I don't go through that wall, that asymptote that I'm coming up on. And if you're not sure where that point is, just keep scrolling along in your table until you start getting eerily close to a number, but you're not going past it. Like I'm getting really close to -2 now, but I'm not going past. So that tells me a lot about my range, what's going to be going on in a minute. So here, domain still is not changing. Not going to. My range, though, like Austin was mentioning a minute ago, if this is shifted now below the x-axis, my range shifts with it. My whole graph shifted down to, so now instead of my range starting at 0, my range is starting at -2. And the only thing that otherwise tends to get people on this is sometimes they'll flip these because they work left to right instead. This is bottom of my graph to the top. So any up or down shifts are going to mess with my range. And if I happen to be doing end behavior, they'd also mess with my end behavior. 4 is going to be similar, except now I've got to watch the typing, because this can screw me all up otherwise. My exponent, since the x and the -4 are part of it, I even draw that in like that just to make sure I don't forget. Oops. Because if I forget, I'm going to end up shifting my graph down 4 instead of shifting it, in this case, right 4. I look at the picture, notice it's still hugging the x-axis, but now instead of starting over by 0, it's shifted its way over further. So when I do go to look at the chart of this, my values are going to kind of have shifted on me. So for instance here, if I go all the way back to -3, all of those values are so close to 0, I'm not really going to be able to see very much. So I may even want to come, basically put a dot at basically about 0, 0, and those first 3 dots that I have are basically all going to be hugging right on the x-axis. It's not till I get out to 3 and I start to get a little bit higher that I'm actually going to get a fairly good look at how these are going to work. So we're back to hugging the x-axis. We're back to our range being what we call normal, or like it is in a parent graph. Because I haven't had an up or a down shift, my range is going to be the same as it was in these other ones that didn't have any shifts at all. The only time that range changes is if there's an up or a down shift. Otherwise, it'll just stay at 0 to infinity. So it's just kind of a basic rule that we're going to run with on those. Okay. So if we know the basics, nothing too shabby. So now, speaking of shifts, if f of x equals 7 to the x and g of x equals 7 to the x plus, x minus 3 plus 2, explain how to obtain g of x from f of x. What is the transformation? What are the shifts? Even though I will use the word transformation on the quiz, I'll warn you. What are my 2 transformations in going from this to this? Go for it. Right 3 and up 2. That's what we're looking for. Up or down on the end, left or right's coming up there in your exponent. But that's all I'm asking for. And then the rest of these are all going to be based on applications. Notice you're given the formula that you use for the application in every one of these. So it's not like you're going to have them memorized. You're just going to have to be able to use them. So, for instance, on our first one here, let's bring you down here. The amount of radioactive isotope decreases, decays, 4.5% a year. If a sample originated with 245 grams, my A is always what I'm starting with, so 245. If it decays, I'm going to be subtracting. Do I do 1 minus 4.5?
1 minus 0. No, 0.0 plus 5.
That's right. And since they're asking me how much remains after 15 years, since I actually am given the t this time, I would go ahead and use it. I know some of you still may want to go into the y equals and scroll down to 15, which you could, but I like to keep life simple. So if I have all the information where I can just punch it in and get the answer out, that's the route I'm going. And since I know my t value, since it isn't a mystery, I'm going to go ahead, type that in, and find out after 15 years, I've got about, and normally on things that aren't money, I just round to the nearest whole. So if you wanted to call this 123, if you wanted to call it 122.8, you know, I'm good with any of those because I'm going to know that you were setting things up correctly that way. But that's basically what we're on the lookout for here. Use the formula, plug in the number, churn out answer. But am I always going to have the time available? Not necessarily. For instance, if I can get the calculator to move, there we go. A city's population is currently 45,600. My starting value. But it grows at a 2.3% rate each year. Okay. So similar to the last one, except now we're growing, we're adding. Write an equation to represent the city's population. Then, calculate how many years will pass before the population reaches 60,000. They're not going to give me the time this time. So it's going to be my job to figure that part out. So unless you are a big fan of guess and check and you just want to put in random numbers for t until you find it, I would suggest going to the graphing function, punching your equation in, and again, we just use x. And what I'm going to do is I'm going to bring up the table and I'm going to scroll down until y equals 60,000. So let's see. How long is it going to take to get to 60? Close. There it is. Okay. So somewhere in year 13. If you wrote 12 to 13, because that's the year in the range of what it would be, that's okay too. You could absolutely do that. But either one of those would be perfectly acceptable. So notice the difference. If they give me the time, I just punch it in and get it done. If they want me to figure out the time, I'm going to use the graphing function to help me. Any issues on the front here that you can see so far before we get applying here a little more on the back? Righty, over we go. So back here, we invest part of our summer income in an account that collects 4% interest continuously. There's a new one. How long will it take for the account balance to triple? Now some of you may say, well, wait a minute. How long will it take for it to triple? I don't even know how much I have. At this point, I get to figure out on my own what I want P to be. I can use anything. I'm going to choose to make it 1,000. I'm going to start with $1,000. You can start with 100, a million. It doesn't matter. So I'm going to start with 1,000. E is a value we're going to talk about here in a second. And then my exponent is rate times time. But again, I don't know how long. So here's how this is going to work. How long is it going to take for the account balance to triple? What's my initial investment once it's tripled? What does that equal? 3,000. So depending on what I started with, you're like, now how do I put all this in the calculator? This is the only part that I'm going to put in. So I'm going to go ahead. Holy cow, once I get through all those other crazy things. Hi.
Hi. Are they here today?
Yes. Yes.
Okay.
Thank you.
Mm-hmm.
So what we're going to do is we're going to get this part plugged in. To get E, it's second, and ln, which is down the left side of your calculator. Okay, so to get E, we do second and ln, and notice it already puts it into an exponent form for me, with a parenthesis, even better. So I'll plug in the 0.04, except I'll use x again, like I normally do. And what my job is going to be is to figure out when y equals 3,000. So we'll get the graph up, and we're going to start scrolling down here on the table till there we go, until something over 3,000 shows up. And once it does, well, basically we're set and ready to go. That's a long time to wait for that extra $2,000. 28 years. Need to find a better interest rate. So that's the only thing in with E. That's why we didn't do a whole lesson with all these things with E, because, well, it's just one button and it does everything else for us. So, but again, the concept is going to be the same. When we get to the other interest, which is coming up here on the next couple, I'm going to invest $1,200 in an account. Okay, they gave me a starting value this time. Paying 5% interest. All right. Compounded monthly. What's my end value going to be? How often in a year does monthly occur? 12. So my n value is going to be 12. So the denominator here and the first part of my exponent, find the account balance after 9 years. There's my t. So it's another one of those, I have all the values already. So I don't really need to get fancy. I'm just going to type in what I've got. And if you want to go ahead and multiply the 12 times 9 and not have to worry about the parentheses, that's fine. But if you don't, we need to put the parentheses in. And that'll let me know that after 9 years, shift back over here, and we're talking about money, so I'm going to go ahead and use the cents. We'd have about $1,880.22 in our account using that particular formula. So now we start to go a little further into the application. Determine which is a better investment. $3,000 at 4.5% compounded monthly for 5 years, or $3,000 at 4.3 compounded daily for 5 years. Show your work and explain your choice. Okay, so here for my first option, I've got 3,000 at 4.5, oops, not 45, Harty, 4.5. It's monthly again, so my n's going to be 12, and we're looking at it for 5 years. So my exponent would be 12 times 5. Sorry, my line got through there. And I'd crank that out. My other one starts with the same balance. Still got a little bit different of a percentage, 4.3. Compounded daily. Ooh, what's my n value going to be? 365, because there's 365 days, in most years at least. And so my exponent will be 365 times the 5 years. So I need to figure out here which one of those is going to bring me in the best cash flow. And yes, you could do this in the graphing part and then just kind of look at both of them next to each other. That would work. But I think, again, when I get all the numbers and can do it myself, I'll just go ahead and crank them out individually here. So there's my first one. And then we'll do this one last time. Just to see if either of these is going to have a major difference versus the other. And we find out basically the percentage being higher is the way to go. Explain your choice. I want more money, okay? I know that seems kind of crazy, but again, if you show what you're doing, I mean, basically, which one's the better investment? Duh, the one that makes more money. At least for the 5 years. Now, long term, one might prove to be better than the other, but for right now, that's as good as it gets. So you're like, all right, this isn't too awfully terrible. If a $40,000 car is depreciating at 12% per year, decay, how long till it's worth less than $10,000? Okay. Still start with my initial. It's decay, and it's not interest, so I'm not getting cute here. I'm just going to use my decay formula. And again, I don't know the time, so I got to get a little fancier again. So I'll take it to the x, because again, I want to look at all the different years to find out my answer. So less than 10,000. I started way down there. So 10 looks like to me 11 years. And again, explain how you found your answer. Put that into the calc maybe and followed the table until y was less than 10,000. And you might write it a different way, but that's all you have to do. It's not like I'm giving you a room, you got to write me a 3-paragraph essay. Here's the formula I used, and using that, I found out that when I got to this year, y was less than 10,000. So it's 11. 11 years. That's kind of interesting. But again, it's applying what we've got to what we're doing. Now here's the abstract of abstract. If given the option of 2 investments, describe how to tell which investment accrues more money. You can use a graphical representation, you can use an example, a table representation, or a function property. To me, the easiest one to explain always is just to pop out an example. Now, I would do something similar to number 10, but here would be my difference. We sort of knew that a higher percentage is going to make me more money than a lower one is. So don't do something obvious like this one's 10% compound and this one's 3. The 10%'s better. That's not what I mean. Find something maybe like this, and maybe you kind of split it down the middle and go, okay, $3,000 at 5%, compounded, let's see here. Let's say quarterly for 10 years. Again, I'm just making a situation up for myself. But I want to make my other situation similar enough that I get to see how I do it makes a difference. So I'm going to keep the percentages the same. Now maybe I say compounded daily for 10 years. Just to see, do I really make more money if it's daily rather than quarterly? I'm not sure. And at that point, you would just calculate it, find the 2 values, and then basically say, if it compounds more, it's going to be worth more money. But if I want to prove it, and since I have my values, I'm going to clear this out, I just keep pounding that interest formula. The only time you use the interest formula, of course, is when you're calculating interest. Quarterly be 4 times a year. And I'm doing it for t equals 10 years. And again, it's those same 2 formulas that we had in the notes that you're basically using. This one for interest. And I'll calculate both of these. Again, same percentage, same number of years. The only difference is going to be my end value. And hopefully that's going to give us some background. Now, am I going to retire on the extra $15+ I make? No. But it does show that overall, in basic terms, the more you compound, the more money I'm going to make. So if it compounds, quarterly versus weekly, weekly would be more. It compounds more often. But daily is better than weekly because daily has more than weekly does. just to be able to explain somehow how that works. And if you want to use one of the other representations, you can. And then finally, a little of the stuff from yesterday. Again, make sure you've got the same base before you start. Okay, this guy is 3. I can turn that into 3. How am I going to turn 9 into a base of 3? 3 squared. Once I have the bases the same, I basically ignore the bases and just work with the exponents. And solve it like I would any algebra equation from Algebra 1. But again, make sure that whatever that exponent is, you're distributing it through. So let's see, 4 minus that over, and fractions are absolutely legal. Oops, got in my x. I'm not going to be doing much of anything. But the whole key is going to be looking at these, even if I throw a twist in at you like this, remember, fractions equal negative exponents. 3 to what power gets me 9? 2. But since it flipped itself into a fraction, it's negative 2. Ooh, the bases are already the same. Very nice. Nothing to distribute because there's no other value except the base here. And I just add the 2. I just add the 4 over. Can I take 4 to some power to get 8? No. Well, now what do? I can't take 4 to some power to get 8. Yeah. We're going to turn them into bases of 2. Because 2 squared is 4. 2 to the third is 8. And distribute, I'm even going to write it so I remember to, your exponent times your second exponent, your power actually. And again, just solve it like you would any old equation. Now, like I've said before, and like we do on all the quizzes, I'll have a blank copy of this online, I'll have the key online, and I'll also have the video of this online. So if you're having some issues, you can go back and check those. Because tomorrow when you come in, it will be into quiz mode, and maybe, just maybe, we'll get to the future of testing sheet then once that's situated.